Okay, so welcome everyone. Some of you may have been with us for a while now since we've been recording for a little bit, but just wanted to welcome you to today's Bigger Wellness webinar on climate reality. And one of our own members, Friends Life Care member Margherita is going to be presenting for us. So she is a graduate of the Climate Reality Project Training Program, and we are very happy to have you here, Margherita. So thank you very much for joining us. And Margherita has asked that we wait and we hold questions till the end. You can put them in the Q&A box at any time, but she said that she's found that people often ask questions that are that she answers later in her presentation. But if you have any problems understanding what she's saying, or you have, you need anything clarified about what she's talking about, you can let me know. And if Margherita's okay, I'll stop and just ask you those questions. All right. So Margherita, I am going to stop sharing so you can share your slides now.
Okay, great. So,
and I'm going to turn my camera off so people can focus.
There is no glitch.
All right, thank you very much.
Okay, you should be seeing a black screen with a blue line across it.
Yeah, that's what we have on our screens right now. So that's
okay, great. That's the first slide of my slideshow. So that's where we will start. Okay. So I first became interested in climate change after watching Al Gore's documentary film more than a decade ago. Since then, I followed developments in the field with increasing interest and concern, and I'm especially troubled by the prevalence of climate change denial. Global warming is established science. Its cause, increased carbon dioxide in the atmosphere, has been known for more than 70 years. At this time, there are only 3 questions remaining about the climate crisis. My presentation to you today is an attempt to look at these. The first is, must we change? The scientific community has been telling us for a long time that we must. Now Mother Nature is doing so as well. The second question is, can we change? And finally, the third question is, will we change? So let's start by reviewing the science and addressing that first question. This photo on your screen shows the thin shell of Earth's atmosphere. We see it here as it is seen from the International Space Station. The sun is rising and shining through the 2 lowermost layers of atmosphere, the troposphere and the stratosphere. We imagine when we look up into the sky from the ground that it is a vast expanse, but actually it is just a thin shell. Okay, this is the basic science of global warming. It's understood by scientists since the 1800s. Energy from the sun comes to Earth as light or electromagnetic radiation. This energy is absorbed by the Earth and its atmosphere and warms it. Some of the energy is then re-radiated back into space in the form of infrared or heat waves. And some of this energy that's re-radiated is again trapped by the atmosphere, bounces back to Earth and warms it further. This process maintains a stable temperature for all life on Earth. Now we are thickening this atmosphere by adding chemicals to it that increase its ability to trap heat. This is upsetting the balance and warming the planet. So where does all this chemical pollution come from? This slide shows us multiple sources of greenhouse gas emissions. Thawing permafrost, coal mining, industrial processes and coal plants, industrial agriculture, landfill, crop burning and fertilization, forest burning, oil production, land and air transport. Let's look at some numbers. In terms of numbers, here are sources of greenhouse gas emissions. Production of electricity results in 25% of them, production of food 24%, heavy industry 21%, and transportation 14%. Notice that 3 of the 4 relate to the fossil fuel industry. The 4th is agriculture and food production. Its greenhouse gas emissions, methane, are produced by land animals raised for food, open burning of agricultural waste, and rice paddy cultivation. Also, forests cleared for agricultural use result in a decrease in land available to sequester carbon dioxide. Now, I mentioned methane here, so let's look at that next. About 25% of global warming is due to methane. Sources of methane emission include thawing permafrost, landfill decay, methane emitted by livestock, and leaks from the fossil fuel industry. Methane remains in the atmosphere about 12 years, so it's short-lived, but it is 8 times more potent a greenhouse gas than carbon dioxide. Agriculture and the fossil fuel industry contribute equally to this problem. Overall, the largest source of global warming pollution is the burning of fossil fuels. Fossil fuels still supply more than 80% of the world's energy. Fossil fuel use and its related emissions have increased dramatically since World War II. They add the pollutants, the carbon dioxide, methane, nitrous oxide, and water vapor to the atmosphere. Because of this, summer temperatures have shifted. Each decade is warmer than the previous one. This is the baseline from 1951 to 1980. And notice what happens with each decade. The curve flattens out and it develops a bright red tail. That bright red tail is the incidence of extremely hot temperature events. These events used to cover 0.1% of the Earth. Now they cover 14.5%. This slide shows us global surface temperatures and their departure from average over the span 1880 to 2019. Notice what's happened in the past 40 years. Temperatures each year have gone up, year after year after year. Global temperatures have increased dramatically because of the pollutants that are being trapped in the atmosphere. Because of this, January 2020 was the warmest January on record. More than 80% of the energy of increased temperatures is stored in the world's oceans. This slide shows you global ocean heat content. Notice the pale blue section. That's the increase in ocean surface heat from surface to 300 meters of depth. It's increased dramatically. And half this increase has occurred in less than 20 years. This increase in ocean surface temperatures and heat content has vast implications for our weather. Because of the heat stored in the oceans, ocean temperatures are setting new records decade after decade. Notice the past 20 years. Each year has been hotter than the previous one. So you might be asking yourself, why does this matter? What's bad about warm water? Well, increased ocean temperatures provide fuel for more severe hurricanes. This means more water vapor rises into the atmosphere and is stored there. It leads to more and heavier downpours. You might remember Hurricane Harvey in 2017. It crossed waters of the Gulf of Mexico up to 7 degrees Fahrenheit hotter than normal, up to 200 meters deep. This resulted in a huge downpour over Houston. And Hurricane Harvey was not an isolated incident. Houston has been hit by 10 major flood events and 3 1-in-1,000-year downpours from May of 2015 to September of 2019. And then there are incidents that are closer to home. Does anybody remember Hurricane Sandy? In 1880, that would have been a 1-in-500-year event. In 2017, it would have been a 1-in-25-year event. By 2030, we can expect this once in every 5 years. And January to June 2019 was the wettest such period on record for the contiguous United States. But it's not just the United States. Globally, floods and extreme rainfall events now occur 4 times more often than they did in 1980. And here's a slide that shows you that. Notice the spikes in 2010, 2016. But it's not just precipitation. It's all sorts of extreme weather catastrophes. Notice especially the red tips on top of each bar. These are the incidents of extreme temperatures, droughts, and fires. The same extra heat that evaporates more water from the ocean, causing bigger downpours and floods, pulls moisture even more quickly from the soil, causing longer and deeper droughts. So you have dry vegetation, dry land, higher temperatures. The result of that is fires. Since 1972, the average area burned each year in California has increased 500%. In October 2014, the U.S. Department of Defense published its Climate Change Adaptation Roadmap. In it, it made this statement: Climate change will likely lead to food and water shortages, pandemic disease, and disputes over refugees and resources, as well as destruction by natural disasters in regions across the globe. So let's look now at global systems that are vulnerable to climate and its disruptions. Let's look at food supply first. Increased temperatures, pests, and extended ranges for diseases all cause stress for crops. Crops respond to these stressors in various ways that are problematic for their use as food sources. This picture shows crop damage in the Yucatan Peninsula in western Mexico. I think there's been under-recognition of just how sensitive crops are to heat and just how fast heat exposure is increasing. And here are projected yield declines for each degree centigrade of global warming. These 4 crops make up 2/3 of human caloric intake, either directly or indirectly by feeding animals that we then kill for food. Nose to drops, corn is more than 7%, wheat more than 6%, rice and soy more than 3%. These drops are already occurring. The global mean temperature has already gone past 1 degree centigrade over pre-industrial in 2015. So we've already experienced these yield declines and they will continue. Increased temperatures and drought results in toxin accumulation in crops. This also makes them more vulnerable to pests and diseases like aflatoxin and wheat rust. In addition, heat stress results in accumulation of nitrates as plants produce less protein. Increased carbon dioxide by itself results in decreases in trace mineral content, zinc, iron, copper, magnesium, and calcium. In addition, increased carbon dioxide itself also results in decreased protein production by plants, as well as an increase in nitrate content. So plants respond to both heat stress and increased carbon dioxide in ways that are problematic. And rising concentrations of carbon dioxide are affecting global nutrition by reducing levels of nutrients in food crops like rice, wheat, and soybeans. Because of this, there may be a threshold of global warming beyond which current agricultural practices can no longer support large human civilizations. So now let's look at water. This is how the global water pie is divided up. Notice that 69% of the global water use is due to agriculture. In the United States, agriculture uses 80% of our country's water supply. So how does climate change affect water availability? It reduces supply through drought, sea level rise, melting ice, and runoff, increases demand across all uses. So as temperatures rise, water use rises as well by people, crops, energy industry, and animals. And water scarcity already affects more than 40% of the world's population, and climate change is going to make this problem worse. Finally, let's look at global health issues. Climate change causes extreme heat, air pollution, decreased food and water, and increased pests causing disease. These all affect global health. Because of that, climate change is the biggest global health threat of the 21st century. So why? Climate change is disrupting natural ecosystems in a way that's making life better for infectious diseases while it's making it worse for humanity. And here's an example of that. Tropical diseases on the move. Tropical diseases caused by disease vectors are no longer staying in the tropics. They're moving to temperate zones, both above and below the equator. And it's not just diseases caused by insect vectors. Bacterial diseases like cholera and Vibrio also like warm weather. So the warmer the earth gets and the warmer the water gets, the more these diseases are going to like it. Climate change will make bacterial diseases like cholera and Vibrio much worse. Remember that more than 90% of increased planetary heat is being stored in the world's oceans. This results in an increase in annual ocean heat waves. Notice the spikes in the year 2000 and beyond to 2020. So why does that matter? Well, warm waters, especially ocean waters, have many effects. So marine heat waves are doubling in frequency since 1982 and will occur 20 times more often with 2 degrees warming and 50 times more often if emissions continue to increase strongly. This fact is actually a problem because the effects of warm water, especially ocean waters, are really a problem for humanity. So let's look now at a few of these effects. One of the effects of increased water temperatures is the growth of algae blooms. Algae blooms produce neurotoxins. So this results in the close of fisheries to protect us against neurotoxins. But algae blooms also do something else. They use oxygen. So an algae bloom results in the growth of oxygen-depleted dead zones. Notice the dead zones along the coastal regions of the United States and parts of Europe and Asia. And also there are open ocean dead zones as well. These dead zones are disastrous for all life forms existing in these regions. Along with increased water temperatures, ocean surface waters are in equilibrium with the atmosphere. Carbon dioxide from the atmosphere dissolves in surface waters. This makes the ocean water more acidic and causes problems for marine life, especially for shellfish and coral reefs. What happens is the acidic water dissolves the shells of shellfish. This has effects that results in their death, and therefore is less food for larger animals that depend on them for food, and ultimately for us as well. Another effect of warming oceans is melting ice, especially Arctic ice. The Arctic Ocean is surrounded by continents, and it's been totally ice covered for millennia until recently. Notice the drop in Arctic ice extent around the year 2000. So what are the effects of melting Arctic sea ice? Well, it does not raise sea levels because this ice is on the sea, not on the land. It does result in a feedback loop. Ice cover in ocean water reflects sunlight. Without that ice cover, water absorbs the heat from sunlight. This results in warmer ocean water and further ice melt. The Arctic is warming more than twice as fast as the rest of the globe. The iconic climate change issue involving the world's oceans may be the issue of sea level rise. Increased ocean water temperatures result in increased water volume, even without any extra water being added to the system. But there's actually plenty of water being added. The largest sources are land ice on Greenland and the Antarctic. NASA's concern about this problem is its irreversibility. Once started, this trend may become impossible to stop or to reverse. Greenland has had multiple episodic ice melts of its surface waters. And by itself, Greenland has had enough water stored as land ice to raise sea levels worldwide by more than 6 feet. And then there's the Antarctic, which is increasing ice loss per year in billions of metric tons. It's an accelerating increase of melt. And the effects of sea level rise are already occurring and will worsen over the next 50 years. At the current accelerating rate of increase, NASA expects a sea level rise of more than 26 inches by 2100. More than 35% of the world's population live on coastal plains. So a large number of people are at risk from sea level rise. So let's look at some of this. By 2070, the top 10 cities at risk from sea level rise are shown on this slide. Notice that the top 4 will have populations of more than 10 million people each. That's going to be a lot of climate change refugees. You have to wonder where these people are going to migrate to. There's another way of looking at this issue, and that's in terms of assets at risk. In this slide, it shows you 10 different cities. 2 of the top 10 are East Coast cities, Miami and the New York, Newark area. Miami is especially troublesome. It is already experiencing sunny day tidal flooding. If you own real estate in an area like this that is flooding, you may be trapped. You may not be able to sell your home to leave. And in fact, in the United States, 12 million people could lose their homes due to sea level rise with a warming of 2 degrees centigrade. So all these effects are telling us that we must change how we live, answering that first climate question with a yes. The growing awareness of fossil fuel contribution to all these problems is leading to a growing understanding of its cost to society if we continue to use it. But in addition, the fossil fuel industry is under pressure by competition from new technology, that of renewable energy sources. So let's look next at this issue. A good place to start is this quote about carbon reserves. Mark Carney, Governor Bank of England, October 2014, made the statement, the vast majority of carbon reserves are unburnable. So you might say to yourself, what does he mean by this? Well, let's look at the subprime carbon bubble, a take on the subprime real estate bubble about a decade ago. Here's the first donut. All fossil fuels burned from 1850 to 2010, and the donut hole burned since the year 2000. So that's the past situation. Now look at the present to future. The red circle is the amount of fossil fuel reserves remaining. And the burnable amount is the donut hole. The burnable amount is the amount that we can use and still keep our global heat temperature below 2 degrees centigrade. So the red donut are unburnable assets. They're worth $22 trillion. These are stranded assets, unless of course you want to cook the planet. And then there's this, energy sector returns. Notice how badly fossil fuel companies are doing in comparison with clean energy companies. These are returns since January 2017. But as of February 2020, 1,200 institutions with managed funds worth more than $14 trillion have pledged to divest their assets in fossil fuel companies. If you have money in a retirement account and that money is invested in stock in the fossil fuel industries, your money, your assets are also at risk along with these companies. Now, how have fossil fuel industries survived? Well, they're being supported by subsidies around the globe. Here's a comparison with renewable energy companies. Notice the difference in subsidy. This keeps fossil fuel companies afloat. And here's a US subsidy as well. According to a 2018 study, up to $4 trillion worth of fossil fuel assets may be wiped out of the global economy due to changes in technology and related markets. Also, there's an increased social and reputational risk for fossil fuel companies. Investors now perceive that they're problematic because of climate change. So financial support and subsidy to these companies is not going to save them. So all these issues lead us to the second question, can we change? Well, actually, we now have a new option for energy production. Renewables like wind and solar offer viable, cost-effective solutions. These will surpass the fossil fuel industry and supplant it. So let's move on and look at this. Let's look at green energy progress. In the year 2000, the projection was the worldwide wind capacity would reach 30 gigawatts by 2010. By 2019, this goal was exceeded by a factor of 22. And here's a graph that shows you the ramp up in capacity. It's an exponential increase from 1980 to the present. And here's a US wind energy capacity as well. Global wind power will be a $3 billion industry by 2040 with millions of jobs. So the reason this is happening is increased capacity is due to decreased costs. Decreased costs are due to massive technological improvements that makes wind costs cheap and accessible. And it doesn't get any cheaper than free. Texas has a lot of wind energy, and some utilities in Texas are now offering free electricity at night because wind energy is so abundant. And globally, wind could supply worldwide electricity consumption 40 times over. So the supply is actually huge. Then there's solar. In 2002, the projection was that the solar energy market would grow by 1 gigawatt per year by 2010. The reality was exceeded 17 times. By 2019, it was exceeded by 121 times. And here's a graph that shows you that. Notice a sharp exponential increase with a takeoff at around the year 2005. And here's the US graph that shows you the same thing. You know, solar has been around since the 1970s. In 1976, it cost $79.40 to produce a watt of energy using solar. Its capacity has increased considerably in recent decades due to decreased costs, driven by increased technological advances. In 2019, it only cost 25 cents to produce a lot of electricity using solar. And the available supply is huge. Enough solar energy reaches Earth every hour to fulfill all world's energy needs for a full year. Because of these issues, in January 2015, Deutsche Bank made the following statement: that we believe the trend is clear. Grid parity without subsidy is already here. Increasing parity will occur, and solar penetration rates are set to ramp worldwide. And actually, I've just shown you two graphs that show you the ramp up. It's an exponential increase. Because that's investors know a good thing when they're seeing it and are increasingly putting their investment money into renewables rather than into the fossil fuel industry. And here's the future over the next decade. Notice there's a small, stable amount of investment money going into nuclear. Most of the increase in renewable energy investment is into wind, solar, and battery production. So what about battery production? Storage capacity. This shows you global cumulative storage capacity from 2011 to 2016. Notice it's a gradual increase. Here's the projection out to 2040. It's an exponential increase. Notice in 2040, we're expected to have 1,000 gigawatts of storage capacity worldwide. 1,000 gigawatts is 1 terawatt. Daily world consumption of energy from all sources scales in the teens of terawatts. So to have a terawatt of storage available worldwide is a functional amount to start with. So you may say, well, why is this important? Why do we need battery storage? Well, the wind doesn't always blow and the sun doesn't always shine. So we need to be able to store the excess energy that the system produces in order to use it when the system is shut down. So storage capacity is actually really important. A modern grid will have wind, solar, and battery as 3 prongs that encompass it. And here's a timeline for projected transition from fossil fuels to wind and solar. In 2014, electricity from solar and wind was cheaper than new coal and gas plants in 1% of the world. By 2019, 5 years later, wind and solar provide the cheapest sources of electricity in 2/3 of the world. By 2024, wind and solar is expected to provide the cheapest electricity in the entire world. For many consumers, home lighting and automobile use are important issues. So let's look next at these areas. By 2025, the estimate is that LED lights will capture 95% of the total lighting in the market. The reason for this is improvements in technology and decreased cost. Then there are powertrain issues. Efficient fossil fuel cars are becoming more expensive because there are new emission standards imposed on their engines. Mainstream battery electric cars are becoming cheaper because of improvements in technology. The crossover is going to occur within a couple of years. The transportation sector is a large source of greenhouse gas emissions, so this is important. This statement was made by BNP Paribas in September 2019. This is a global investment and financial company. We conclude that the economics of oil for gasoline and diesel vehicles versus wind and solar powered electric vehicles are now in relentless and irreversible decline, with far-reaching implications for both policymakers and the oil majors. So let's look briefly at global electric cars on the road. By 2018, there were 5 million electric cars. To put this in context, the global size of the individual auto market is about 1 billion cars. The US contribution to this is 250 million. So this changeover is going to demand a lot of individual decisions and will require decades. Decreases in battery costs and pressures by governments will speed the transition, but still a lot of individual decisions. Let's look at how quickly this could change when fewer purchasers are involved. Almost all buses are fleet purchases by countries, states, cities, large companies. Notice how quickly this is changing. So the answer to the second question, can we change, is yes, we have the technology available to do so. Ultimately, the shift to renewable technologies and away from fossil fuels has two drivers. One of these is social consciousness and concern over climate change. The other is the financial pressures that renewable energy technology exerts on the fossil fuel industry. Both are at play. So the final question, will we change, is currently being answered. This statement was made by Goldman Sachs in November 2016 after that presidential election. That we expect that innovation in global markets rather than politics continue to be a primary driver for the growth in low carbon technologies. In our view, prices for batteries and solar panels will continue to drop, and global market share gains will continue for wind, solar, EVs, and LEDs. And if you think back to the slides I've already shown you, those slides actually demonstrate that this prediction was correct. And they ended with this comment that this was going to occur regardless of who occupies the White House, namely that governments and politics don't matter. Well, the United Nations would disagree with Goldman Sachs. Because the United Nations believes the government action matters, it has spent most of the past 25 years attempting to enlist support for climate action from all the world's governments. Its leadership first resulted in the Kyoto Accords in 1997 and followed that with the Paris Agreement in 2014. So what is this about IPCC? This is a global agreement to tackle climate change. The December 2014 meeting in Paris resulted in the Paris Accord. This provides an ongoing framework for measuring, reporting, and verifying emission standards by world governments over time. Included in this is the capacity to progressively strengthen the plan over time to make the reductions more stringent, with reassessments to occur every 5 years. This past year, the reassessment was supposed to occur at a meeting in Glasgow, Scotland. It was postponed a year because of COVID. In the IPCC agreement, the Paris Accord, each government agrees to first limit its country's emissions to achieve net zero by 2050, to establish its own NDC, nationally determined contribution, to accomplish this. All NDCs are voluntary, and no penalties incurred if a country fails to meet its goal. So what are IPCC's goals? The first is to limit global temperature increase to 1.5 degrees. Its plan, a 45% decrease in CO2 emissions by 2030, and 100% net decrease by 2050. In comparison, the decrease resulting from COVID-19 was a 10% drop in emissions for 6 months. Right now, the global mean temperature has exceeded 1 degree centigrade above pre-industrial in 2015. With business as usual, it will reach 1.5 degrees above pre-industrial between 2030 and 2050. Right now, the world's biggest polluter is China. But the US historically has produced much of the emissions, leading to our current situation. Over the past few decades, there have been periods when the US federal government has not been especially proactive in dealing with this. However, in the absence of federal leadership, the US has still moved forward with commitments to renewable energy sources. And here are 2 examples. The US Climate Alliance. This is voluntary, bipartisan, and encompassed 26 states and territories. It started in 2015. The Climate Alliance commits to achieving IPCC's goals with a 25 to 28% reduction in emissions from 205 levels by 2050. Then there's RGGI, the Regional Greenhouse Gas Emission. This is a bipartisan agreement that started in 2009. and imposed a mandatory cap and trade on greenhouse gas emissions produced by the power industry. This is important because, first of all, it's mandatory, and secondly, the location. The region is every state from New England and the Middle Atlantic states from Maine to Virginia is part of this initiative, except for Pennsylvania. Pennsylvania right now is in the process of discussing in the legislature of our state whether or not to join RGGI. So even though the US federal government has said no at times in the past 2 decades, many US communities as well as US and global companies have said yes. The effect of US government's lack of support at the federal level to combat climate change has slowed US transitions away from federal fossil fuels into renewables, but has not stopped the process. This slide is as of 2019. And it's not just communities and governments, it's also companies. The Wall Street Journal published a statement in August of 2019. The Business Roundtable is a group of US companies with a global reach. Their combined revenues in excess of $7 trillion, so they're large companies. Their CEO stated changed its statement for the purpose of a corporation. No longer should decisions be based solely on whether they will yield higher profits for shareholders, the group said, but rather corporate leaders should take into account all stakeholders, employees, customers, and society at large. This is almost certainly due to social pressure from activists and from shareholders in their companies. And it's not just US companies. Over 220 global companies have also made a commitment to 100% renewable, also due to social pressure. So we looked at the problems that fossil fuel use has caused, along with the rise and increasing transition to wind and solar. So to end this lecture, I want to leave you with one issue to consider. And that's this. Will the transition occur quickly enough to limit the effects of climate change to 1 degree centigrade? That is unknowable at this time, and yes, the future of our world does depend on this answer. To produce this slideshow and lecture, I've used slides mostly from Climate Reality Project, and also inserted a few of my personal slides. My personal slides use information from Ipcc, from climate.nasa.gov, and from the Climate and Clean Air Coalition. I started my journey by reading and watching the film by Al Gore. There's now a sequel to both the film and the book. The sequel to Inconvenient Truth is called Inconvenient Sequel, Truth to Power. And you can get these on Amazon, both the book and the movie. So I've stopped screen sharing now. I'll take questions.
Margherita, I think you have to give me permission now that you're the host. I can't get my video on.
Oh my gosh. Okay, so how do I do
That's okay. It's no big deal. If I can't, that's fine. But no, thank you so much. That was absolutely fascinating. Really, really interesting. Is in the beginning extremely terrifying, but it left some hope that things can change and can turn around. So that's really wonderful. Really appreciate that. And just wanted to let everybody know too, all the references that you showed at the end and the resources are on the handout that you received in the link in the email, the reminder email this morning, an hour before the webinar. There's a link to the handout that has those references and as well as an outline. And Margherita, thank you so much for sharing that information with us. It's something that everybody needs to know. So really appreciate that. And there's no problem with the video. Don't worry about that.
Yeah, I'm having trouble figuring out how to do this. I'm
sorry.
That's
okay. Absolutely, you're the star, so that's absolutely fine. It's no problem. So somebody has a question. What would be the most important change an individual can make?
Wow, there's no one change. There are a couple related changes. If you look at the way your current lifestyle is going, do you have a fossil fuel car? Could you change to get a hybrid or electric vehicle? Where do you get your electricity in your house? If you're getting it from Pico, you could ask Pico to get your electricity from a renewable source. Pico gives you that option. They don't publicize this because they don't want people to do it, but you can do that. Another thing is looking at how you recycle. Does recycling matter? Well, landfills produce methane, so recycling matters. Another thing you can do, which is more disruptive depending upon how you feel about this, one of the things that it's really bad about agriculture is it produces a lot of methane. Methane is low-hanging fruit. If we can eliminate or decrease methane production, we can really make an impact on global temperatures. And it's a quick impact because methane doesn't last long in the atmosphere. One way as an individual you can decrease methane production is by going to a plant-based diet. You know, fruits, vegetables, grains, soy, and even eggs produced by free-ranging hens produce a lot less carbon dioxide and methane. Beef production produces a huge amount of methane. So if you stop eating red meat, people cringe when I say this, but that's actually a personal thing that you can do to lower your carbon footprint. Another thing you can do, which also people kind of wonder about, is this really matter? Does this really matter? Is you can become a bit more of an activist. You can find out what's going on in your community, which companies and organizations are producing a lot of fossil fuels, and get them to decrease their use, to change their ways. In Philadelphia County, the two biggest producers of fossil fuels are a bit of a surprise. They're University of Penn and Temple.
Oh,
Yeah, surprise, surprise.
that's very interesting. Yes.
Another thing, we used to have a mega producer. There was a big refinery in Southwest Philadelphia that has since closed. You may know about that in Southwark. If you drive to the airport, there are all these big oil tanks sitting there.
Mm-hmm.
That company used to produce a lot of fossil fuels, but they have since gone out of business. So the real trick now is to do remediation and clean up the site and make that site into a region that has companies that support greenhouse gas initiatives, or at least do not add to the problem.
That's very interesting. Thank you.
Yeah.
Now, I have a question about electric cars. So I've heard there's a question, there's actually a two-part question, because one thing I've heard about electric is they're great, except when you go to get rid of them, the battery is a huge pollution problem. And then the second question is, has any progress been made in the time it takes to recharge an electric car? For someone that wants to take long trips, that's kind of been a setback before. It's kind of been a deterrent to have an electric car because you wouldn't be able to go very far. So do you know anything about either one of those?
I know a few things about each of them. These are not meant to be all inclusive, but the things that I know about them. Battery reuse and recycling is an issue. And there are companies who are working on that issue, because actually there are things in batteries, small trace amounts of minerals that are used to make the batteries efficient, that are actually hard to mine. So if they can recapture the contents of the mineral contents of the battery and reuse it, that actually is good. And it will make new batteries cheaper to produce.
Oh,
So
that's always good news.
That's an issue being worked on, okay, both in this country and abroad. In terms of the recharging issue, there are two issues. One is that as batteries become more efficient, the range that you're going to get is going to increase. It's not unreasonable to realize that over the next couple of years, you're going to be able to get a car that has a battery range of 300 miles. So that's going to help. The other thing that's going to help is to have charging stations nationwide. Excuse me. Some countries, mostly in Europe, already have that. And also their travel distances are shorter. In this country, it's more of an issue, but as the electric vehicle charging stations get scattered nationwide, they're going to be as ubiquitous as gas stations, so you're going to be able to recharge. There's another issue involved in recharging, which is where is that energy coming from? I don't know if you've seen photographs of this online, but they're available. Tesla has charging stations that it's scattering countrywide. Those charging stations all have battery storage and solar panels above them. So if you're charging your car at one of those stations, you're getting energy from the sun. You're not getting it from the electric grid. And that matters because it doesn't make sense to get your energy, you get your electric vehicle charging energy from the grid if the grid is burning fossil fuels to give you that energy.
Mm-hmm. Oh, that's very interesting. I always wondered about that too. That's very interesting. Like, where does the electricity come from? Okay, that's very encouraging news. And someone had a question about airplane travel and how that impacts the environment.
Yeah, actually, that's a problem. This is really funny, but there are companies that are working on the development of using electric engines for cars rather than oil. I mean, for planes rather than oil. Right now, all airplanes fly because they are burning fossil fuels. The problem with using batteries, electric batteries to run an airplane engine is the batteries are too heavy.
Mm.
So because of that, that's going to be a problem. One reason to try to cut out fossil fuel use for ground transportation is because that's low hanging fruit. It's easier to do that with diesel, if you get rid of diesel engines and automobile engines, that is to get rid of airplane engines. But at some point, we're going to head in that direction. It's probably going to take a decade or more to get batteries to the point where they're small enough that you can actually put batteries in an airplane that's not going to be too heavy to make it practical.
Very interesting. Well, it's encouraging down the road. And I've had one more transportation question back to the electric cars. Because someone said it's not about having charging stations, but how long does it take to charge? So if you're on a trip, you've gone 300 miles and then you have to sit there for 4 hours for your car to charge again. So I have no idea how long it takes, but do you know?
Well, yeah, I don't know how widespread this is, but Tesla has charging stations now that decrease that to 15 or 20 minutes. But I don't know if they're just limited to Tesla cars or if they're going to be available to other electric vehicles as well. So I think that's a situation in terms of charging speed. That is a situation which is rapidly improving.
Interesting. Interesting.
That's
very, very good news.
Yeah, this stuff is not really publicized very much. One of the big barriers to electric vehicle use at this point actually is not charging stations, but if you go to a typical dealership and you want to buy an electric vehicle, say if you go to like a Ford Motor or a GM dealership, they don't encourage it. They push you away from that toward fossil fuel vehicles.
Interesting.
One of the issues for that is that if you buy a fossil fuel car, the dealership knows you're going to reappear for oil checks, for machine checks, machine repairs. But if you buy an electric vehicle, they're never going to see you again.
Very interesting. Very interesting. Well, that makes a lot of sense. The bottom line is what counts, right? So that's what they're going to. Very interesting. And then what about people that live in a city and the street park cars? Like, where are they going to charge if they can't have a charging station outside their home or that sort of thing? That seems like that could be the problem.
Yeah, I actually am a bit concerned about that. And my personal circumstances is I live in a condo in a building in Northern Liberties in Philadelphia. So it's an old warehouse that got rehabbed in the lofts about 15 years ago. There are 132 units, about 14 commercial units. We have a parking lot outdoors. Everyone who lives here, who has a condo, or lives in one of the units, gets one parking spot. There are no charging stations on the lot.
Mm-hmm.
Now, I have a really old car and I haven't replaced it yet. And I'm thinking, if I replace it with an electric vehicle, I'm not going to have any place to charge it.
Mm-hmm.
I think what's going to happen is that people who replace their cars more frequently, who live here also, at some point, some of these people are going to show up in the condo association's office and push for charging stations.
Mm-hmm.
Some apartment buildings in Center City are starting to put a few charging stations in their parking facilities, but it's not widespread yet.
Mm-hmm. Interesting. And as you say, as they improve the batteries and the battery storage and the mileage and that sort of thing, I'm sure that will evolve over time. So just like everything else does. So that's encouraging, but that's a real thing to think about. Yeah, definitely. Could it be a deterrent to people right now? There's
something really cute that I found out. You can Google this and find it out. It was published by the Washington Post online. Google Aptera, Aptera. This is going to end up being a niche product. It is a small 3-wheel electric car. It has 2 wheels in front and 1 in the back. It's fully electric. You can plug it into a charger. It's small, it's light, and it also has a solar panel on its roof.
Oh, okay. And would you spell that again? APGERA?
No, APT. T is
Oh, TERA. Okay.
Actuary. It looks like a Batmobile. So be prepared to be
Interesting.
surprised when you see it. It's being sold by a small private company in California. They just started selling them. They have like 7,500 people on their waiting list. They're charging $25,000 for this car.
Oh, wow. Wow. That's amazing.
So I don't know. I think that this is a sort of car that if you have a couple kids, you're not going to be able to buy this. It's a two-seater.
Sure.
If you're a single person who lives in the city, you're using your car mostly to just run around town and do stuff, or a quick trip to the shore with a couple of bags in the back, you know, in the hatchback area that's covered by a solar panel. This is a good car, you know?
So I always worry about when you're in one of those tiny little cars, though, when people have those huge SUVs, that if anybody hit you, you would just be.
Yeah,
No.
I'll tell you, I worry about that a little bit too. That car is probably a bit smaller than what I'm driving, but not a lot smaller.
Right.
I'm driving a Mazda Miata convertible. That's one of the
Oh,
smallest
okay.
cars.
That is pretty small,
Yeah,
right?
it's one of the smallest cars on the road. So I am very careful when I'm around SUVs because an SUV can total me. I mean, I would be like a bug on its windshield, you know?
Right, sure. No, absolutely. Absolutely. Oh, I have another airplane question about how does the number of passengers using an airplane affect the fossil fuel usage? So if you have a half empty plane compared to a full plane, does that make a difference, or is it just,
I'll tell you, actually, no, not for small private planes, but for large commercial jets, most of the weight in that jet is not the passenger weight, but the baggage weight. Not only do, I mean, planes carry passengers' baggage, but they also carry a lot of commercial baggage.
Right. Interesting.
So that's most of the weight in the plane is that baggage. So even during COVID, when there were very, very few passengers, there was still a lot of commercial baggage being schlepped from one place to another.
That makes sense. Absolutely. So, and that definitely makes sense. Well, thank you. Now, question for you. What do you think about the possibility of carbon reduction from the atmosphere?
You know, actually, this is an interesting research issue. There are companies that are working on that. In the past, it hasn't been considered cost effective because if we're worried about parts per million. Right now, the typical carbon dioxide in the atmosphere is like 400 to 410 parts per million. That's a very tiny percent. So it's very hard to pull that out of the atmosphere. So it takes a lot of energy. It's not cost effective. But with the advent of power supplies that are electric, namely wind and solar, it's becoming cost effective to remove small amounts of carbon dioxide from the atmosphere. So now there's a way of, what the companies are doing, they're trying to find a way of using that carbon dioxide commercially to make it won't be just cheap to remove from the atmosphere because we're using wind and solar, but also if we find a use for it. And one of the possible uses is to use it in cement. Because concrete uses carbon dioxide, but actually is part of the production. So if we could use carbon dioxide from the atmosphere to produce cement, that actually be very cost effective and also would help us two ways. One is that we get rid of carbon dioxide from the atmosphere, and also since we're getting the carbon dioxide from the atmosphere using wind and solar, we're not adding to the problem.
Very interesting.
Cement production is one of the uses, when I mentioned early on in the slide, that 14% of carbon dioxide production worldwide is caused by industrial production. That's the industrial production I was talking about.
Oh, I see.
Yeah, the other industrial production is smelt of different heavy metals.
Interesting. There's just so much to learn, isn't there?
Oh, yeah. Since I've really done a lot of reading because it's really fascinating. There's a huge interplay. We live in a world that's very complex. It's complex both in terms of flora and fauna, how Mother Nature's complex in terms of how everything depends on everything else, but also the human society, human embryos, and human life and human society is very complex. So it's not only as an organism are we complex, but the society we produce interweaves in very many ways. That you have agriculture production, you have fuel production, you have different kinds of energy production, different kinds of materials that we use, both hard metals, both battery production, housing. All this is very much interconnected, that you can't change one without changing a whole bunch of other areas of human life.
That's very interesting. Very interesting. So now I have somebody had a comment about methane. They said methane has been identified as a powerful contributor to climate change, and natural gas has been called another name for methane. When natural gas is burned as fuel, it is as destructive as raw methane. Have you heard?
Actually, there are two problems with this. It's not just that you get some methane emission from burning natural gas, for example. But when you're, for example, Pennsylvania is one of the 4 top fracking states in the country. We produce a lot of natural gas through fracking. That produces, as a side effect, a lot of methane, and the companies burn the methane instead of capturing it and capping it. That is a huge problem.
Interesting. Yes, it is absolutely one that really needs to be addressed.
Yeah. One of the things you can do as an individual, especially important in Pennsylvania, is to let your local politicians and your state politicians know what you think about fracking.
Oh, very interesting. No, that's a very important point, because our voices really do count, and we just have to make sure that they're heard.
Exactly.
No,
Exactly.
I agree. Oh, we have one more comment about the electric car. So someone was saying at a recent trip to Morris Arboretum, she spoke to a staff person who was driving an electronic work vehicle. And she said that she congratulated him for having electric vehicles, and then asked how it was charged. And he said, oh, it plugs into the regular building electricity. So in that case, when somebody has an electric car but it uses regular electricity, it's really not doing very much for the environment, right? So, so we're still figuring these things out. It just takes baby steps, right? And we're kind of moving in the right direction with the batteries and that sort of thing.
Yeah, I think it's going to be gradual, but we have reasons to be optimistic. See, even though there are a lot of barriers to the transition to wind, solar, and battery storage and away from fossil fuels, one of the things that really happens, when all things are considered, is that money talks. I mean, when you think about a state like Texas or a state like Indiana or Iowa, you don't think about these people as being tree huggers,
right?
Which is the image that green technology has countrywide. But actually, these people are very pragmatic. There's been a huge growth in wind and solar in those states. It's because it's so cheap.
Oh, absolutely. No, it's wonderful. I mean, what you were showing us about Texas was absolutely fabulous. And free who can argue with that?
Yeah, it's like, you don't think, when you think of Texas, you think of oil companies, okay?
No, absolutely, absolutely. So that's really wonderful. But that's all the questions. Thank you so much. We really appreciate this. You really opened our eyes and gave us hope for the future if we just get moving on it. So really appreciate you taking the time, and really appreciate everyone joining us today. You will receive a short survey, just a 5-question. It'll take you. It's just like you just have to pick one answer for each question. So just take you just a minute or two to complete, and we'd just be interested in your feedback. And also, if there are any webinars that you'd be interested in the future, we'd love to hear about that. And you'll receive a follow-up email, I believe it's tomorrow, that will have a link to this recording and all of our Vigor recordings, and also a link to, if you are interested in our future Vigor programming, that you can check out. So thank you for joining us, and hope to see you on a future webinar. And Margherita, thank you again. That was absolutely fabulous. Really appreciate it.
You're welcome.
Thanks. Take care. Bye.
Bye.